And the floor is yours.
Thank you very much, Pierre, and thanks for everyone for sticking it out through the day. I'm very honored to be able to speak to you today about infrastructure development. It says in Western Canada. I added in a couple slides of Eastern Canada as well, because it's starting to become an issue there as well, where they would like to abate some of their steel mills and things like that in the east. So, from a geologic standpoint, the Western Canada Sedimentary Basin, which is this one here, holds the majority of the rock that is suitable for CCS. There are other areas, extremely remote areas like Hudson Bay, but we're starting to look at this area as well as having some potential for CCS, because there are so many emitters in this area through here, what we call the Golden Horseshoe, and a lot of industrial processes, bauxite, aluminum smelting, and all of those sorts of things. I should add that this all comes at us at a time when Canada has a carbon tax or a carbon price in place that's currently at $65 a ton, but increasing pretty regularly until it's going to reach over $130 a ton. And this is paid by everyone in Canada who fills up their car or buys natural gas, and also the large emitters. There's also, more recently, not unlike 45Q, there is a tax incentive for CCS projects, but the catch is they have to be in place by 2030. So this is a really quick sort of get your project done kind of kick in the pants, as we would say it, to meet 2050 net zero goals. So against the backdrop of all that, we've seen a real resurgence in CCUS. We're a company that started with CCUS in the late 1990s and early 2000s with the Weyburn project, and I'll talk about that. But what's happened in the time since, CCUS sort of fell out of favor for many years, or almost a decade or more, and has become very much in the public eye and very much in the mix of solutions for greenhouse gas mitigation going forward. I'm going to talk about the Alberta experience. You'll see how that has blown up. Some opportunities that are starting to be talked about in Eastern Canada, and then I would be remiss if I didn't talk about Weyburn and Aquastor in Saskatchewan, which some of you may have heard of, and I'll just refresh it for that. But these are projects that have been on the go for at least, in Weyburn's case, 20 years, and in Aquastor's case, about 7 now, or 8. So this is the Western Canada Sedimentary Basin. You can see which part of Canada this is from. North Dakota, where Jim was talking about, is just below this map. This is quite an old map and shows some of the emitters in Alberta and Saskatchewan. And underneath the quest sign is the big one, and that's the Canadian oil sands, where they are generating a lot of steam and heating a lot of water to get that bitumen out of the rock. And I'll talk a little bit more about that later. Aquastor, Weyburn, Quest, and the Alberta Carbon Trunkline are currently the 4 active projects in the country throughout the Western Canada Sedimentary Basin. I should mention here that each province within Canada, when it comes to natural resources, operates almost like its own little country. This was the foundation of Canada, was this power over the decision to mine or to extract oil or to do all this was given to the provinces. So each province has their own regulator when it comes to natural resources. Same with CCS. Each province has their own way of dividing up pore space and giving it to people, and Alberta decided to have a very government-forward method of doing it. They took in a lot of this money from the carbon tax. The carbon tax that's collected across Canada gets redispersed to the province where it came from. And they said they will subsidize projects, but you have to sort of put proposals forward for the storage hubs. Originally, there were supposed to be 6, and those are the 6 listed there throughout central Alberta, and dealing with emitters in mostly refineries in Edmonton and a cement plant and other refineries, but in Alberta, not coal. They have ended coal-fired generation, but still remain with natural gas-fired generation. This is about 18 months ago, or March of 2022. We look at it now, there's 26 potential storage sites identified in Alberta, storage hubs in various stages of development. Some have been drilled. You can see the green ones that have been drilled. That's Quest there. That's some of the other ones, and then one north of Calgary. Very many more are in development at the moment. Also, capture is ongoing. Capture is a little out of my area of expertise, but Heidelberg Cement, a German company that operates in Edmonton, Alberta, is going to be putting a capture plant on a cement plant, which will be one of the first of its kind in the world. Cement plants, in case you don't know, are a little bit difficult when it comes to capture because there's two sources for each plant. You almost have to build two capture plants, one for the natural gas that is burned in order to calcine the limestone. But secondly, the process of creating Portland cement from limestone gives off many hydroxyls, one of which is CO2. So you have two different places to capture it from and put it away. And this is no small expense to Heidelberg and to the people of Alberta who have been funding this. In Ontario, Toronto is up here. This would be Hamilton, where Stelco is looking at injecting CO2 in some formations in the East Coast. I'm not real familiar with the geology here, but I do know that the very first oil well in Canada was not in Alberta or Saskatchewan. It was in 1860 in a place called Petroleum, the aptly named Petroleum, Ontario. That formation is probably not deep enough, but I was just at this place and took this picture, and that is one of the wells from the mid-19th century where they have discovered oil and still produce it to this day. Now, is it as mature and is it ready for CCS the way Alberta is? Absolutely not, but they have some work to continue to do there. In Quebec, the St. Lawrence lowlands or the sediments along the Gulf of St. Lawrence are looked at as being prospective for CCUS as well. There will be intense competition between companies who are looking to inject in these formations. Nova Scotia, offshore and onshore in the east, as you probably know, that we have pretty large oil and gas deposits offshore there, and they're not being looked at for CCUS yet as much as the onshore in Nova Scotia is. Again, more work and time is required for that. Saskatchewan, my province, the one that's the square in the middle, and the joke is always that Saskatchewan's easy to draw but hard to spell. Always gets a little chuckle. That's how you remember where it is. It's this square right here, a rectangle. In 1998 or 1999, I was working for the Provincial Geological Survey in Saskatchewan. I'm a geologist by training, and I was asked to come to a meeting where they were going to talk about this little town called Weyburn and CCS. And my first question was, what is CCS? This is 1999 or 1998. And it is the injection of carbon. They're going to be doing enhanced oil recovery in this level right here, which is the Mississippian Midale beds. So it's about halfway down the geologic column. It's very similar to what Jim showed earlier. We have most of the formations present in a very deep basin called the Williston Basin. And so about 1.5 kilometers down is Weyburn. Aquastor, which I'm going to talk about later, is in the same region, but much, much deeper. That's deep saline storage, and we'll talk about that a bit more. So CO2 is acquired from an anthropogenic source. In the case of Weyburn, it's from the Dakota Gasification Company's coal gasification plant in Beulah, North Dakota. It then travels by pipeline about 250 kilometers to the oil field in Weyburn. The CO2 then mixes with the oil in a what's called a miscible process. So it's not like a piston pushing oil out. It mixes with the oil, deviscosifies, and then is more easy to produce. The oil, this is an important part, has CO2 when it's in it, when it's produced, and that is again separated out from the oil and re-injected. Now, why would the company do that? Why wouldn't they just let that leak into the air? Because they pay $20 to $30, we don't really know, a ton for that. And they're injecting upwards of 8,000 tons per day. That's a lot of money they're paying for a gas that they do not want to lose. So it is in their best interest to ensure it stays there. And what we did at the PTRC and the geologic surveys, we studied the heck out of that field. My master's degree was on the characterization of that field, all the way through to injection and the geochemistry and geophysics and the monitoring. At a time when there was only Sleipner, was the only other one. And, we were sort of breaking ground on what CO2 storage and CO2 EOR even meant. So there's the pipeline, travels from Beulah to Weyburn, and also the Boundary Dam power plant, which travels from Boundary Dam at Estevan over to Weyburn, allowing them to inject, as I said, about 8,000 tons a day. To a total, between the Weyburn field and the Midale field, about 42 million tons since the early 2000s. That's the equivalent of millions of cars off the road, but also the rule of thumb when you're talking about CO2 EOR, it varies a little bit, is about 3 barrels of incremental oil per ton of CO2 that you put in. So that ton of CO2 will loosen up and allow you to generate 3 extra barrels of oil. So that means that they have produced 120 million barrels of additional production. Now, Eric, you're asking me, well, that's not very green, is it? We can have the discussion of life cycle analysis, and Jim and I were talking about it at lunch, that the emissions intensity of those 120 million barrels are among the lowest in the world. And we can I think Jim spoke on that last year, he was telling me, but we can have that discussion in the panel after if you like. The difference between CO2 EOR and CCS with EOR is the MMV, the monitoring, measurement, and verification. And we took it upon ourselves as the PTRC and the survey at the time to figure out different ways of imaging the plume underground, doing the geochemistry, trying to predict the reactions, all of those sorts of things. And one of the biggest revelations at the time was the ability to look at seismic and see seismically where the CO2 is going. This was, at the time, amongst the first time 4D seismic was used in this way. And if you look at these little lines here, they're a little hard to see from the back probably, but those are the horizontal wells. These are all developed horizontally. They're in the shape of a tuning fork. They're called tuning fork wells. And the little dots intervening, those are the injection wells. And what we can see very clearly from 2002 to 4 to 7 and now on as the company continues this on, is the interference pattern that's created by a change in density in the reservoir. And the geophysicists are very confident that that is related to CO2. I'm told not to say there's the CO2, there's the amplitude anomaly related probably to CO2, just to cover everyone's butts. But this was a revelation at the time, and got people talking about, wow, we can really view this stuff in real time. That, along with hundreds of other research projects were undertaken through Weyburn, and you can Google it or ask me and I can give you links to a lot of the papers and so forth that were published. Carrying on with that expertise, in about 2010, we decided to, well, we've looked at EOR, let's look at deep saline aquifer storage. And that was at a time when the Boundary Dam power plant was just undergoing the decision to put a capture plant upon it. Unit 3, this unit right here, this is 1, 2, 3, 4, 5, 6. Each generator is its own unit, and Unit 3 here has this line coming off it leading to this building over here. And that building is where a post-combustion amine capture process takes place. And that plant was decided to be built in 2008. We drilled wells in about 2012. That plant started producing CO2 in 2015, mostly for the sale to the Weyburn field, but also a portion of the CO2 would come to us at Aquastor. In the time since, we've injected 540. I think that's a little bit out of date. We're probably at about 580,000 tons now. So not a massive amount, but as deep saline storage goes, with this much study, it's a very important one. We've injected up to 2,400 tons a day. That was just in case they ever had to send their entire stream to us. We had to make sure that the well would take it. We employ a lot of monitoring technologies on there. We're not trying to do the minimum, we're trying to do the Cadillac of monitoring, just so that we can study what works, what doesn't, what's worth the money, what's not. But keep in mind, this was also a 2012 model year Cadillac. So in the time since the wells were drilled, things like distributed acoustic sensing and DAS, or DAS and other technologies have really come to the forefront and been tested at Aquastor. So there's some more infrastructure, since we're talking about infrastructure. What does it look like when you're in Estevan, Saskatchewan, and thank goodness in the summer or fall? It looks like this, very flat. There's the plant, and there is about 3 kilometers away, there is the well. We did this well and then an observation well 150 meters from it in 2012. The local residents here did not seem perturbed, and they now enjoy munching on wires and things from from some of the geophones that are in the ground. But really, yeah, I'll be very quick. Really, this is the amount of infrastructure, surface footprint that it has. One little building with a loop where they measure the volumes and keep track of the pressures. And this, which is the wellhead next to the building. It's all very closely monitored for pressure. 3136 is the injection depth. 90% of frac pressure is what we're allowed to go to by law, which is about 6,000 psi. We run at about 5,400. Alarms are built into the annulus and everything in case something goes wrong, but the data is reviewed regularly in case we're creating microseismic events or in case there's leakage. Everything is very closely monitored. This is our monitoring program with the 2 wells in the middle, 150 meters apart. We investigate 5.5 kilometers around, which was an arbitrarily decided number at the time. We're talking, 15 years ago. And we put in 630 geophones in a permanently buried geophones in a 2.5 kilometer grid. That allows us to get some very interesting pictures. The cows like eating them. Soil gas. There's little green dots there where we have soil gas locations where we are taking seasonal soil gas. So we're comparing season to season and not worrying about spring versus winter measurements of these things. If there's CO2 in the soil gas, well, it's good that we would have found it, but if the first time we see it is in the soil gas, we've missed something very important along the way. So we're also looking for deformation in the ground, such as INSAR and those sorts of things, all at these sites that are run by solar panels and groundwater wells, and it's all very interesting to keep this all running and keep it all going. We invite companies to come and test their technologies at the site because we have this nicely growing plume, as you can see here. Remember that Weyburn picture I showed? They said, well, it worked at Weyburn at 1,500 meters. You'll never be able to do it at 3,400. And sure enough, here it is again, 36,000 tons. A little anomaly showed up, and we said, there's no way. 102,000 tons. It got a little bigger, 150, 272, and as we speak right now, there is a 580,000 ton survey ongoing to see the plume. The shape of the plume is not a nice circle, as you always sort of get in the pre-drill models, but it is what it is, and we're trying to figure out why there is this sort of demarcation line from the northeast to southwest, and this is all very interesting for the researchers. So, just to sum up, CCUS is probably our main GHG mitigation strategy at the moment. The infrastructure for doing that, such as pipelines and capture plants, they're coming online. That one slide, I should have showed you some of the big pipelines that are being planned from the oil sands in the north to the formations in the south where it can be stored. Pipeline distances, however, need to be minimized. The rule of thumb used to be $1 million a kilometer. That's probably $1.5 million or $2 million now. Each province regulates the CCUS themselves, so that makes for a little bit of a mess sometimes, but we're getting there. Saskatchewan got out of the gates very quickly in the early 2000s, but has been just as quickly surpassed by Alberta. Aquastor and Weyburn together represent not only 40 million tons stored, but also 20 years of knowledge of literally hundreds of scientists, many of you who have met and have presented here. So thank you very much, and we can move on to the panel.